Hello and welcome to our Wednesday discussion in classification. I thought today I would go through kind of a sketch of, anyway, what Deliverable 5 looks like. Keep in mind this is probably not necessarily a passing grade if I were to grade my own work. This is basically something I did more to prove out that the assignment was appropriate, doable, and that there weren't any kind of data issues lurking. Interestingly enough, a lot of times there are. So it is a worthy exercise to do. So that's the primary reason. So take this as, if you choose to observe it, as basically maybe some things to learn that around how I approach the problem, not so much the actual. Take it as the copy this and submit it, and you're going to get a good grade. This is the bare kind of sketch of things. So probably somewhere in that rubric of a 2, maybe a 3. So what I typically do whenever I address these kind of problems is I take the assignment and move it into Markdown inside of my notebook, just so that it's kind of clear what I'm doing. In this case, the first instruction that we're given is to load the libraries, sklearn, pandas, numpy, sklearn ensemble, and model selection, tree, metrics, misspelt. I copied that. I didn't typo it myself, but metrics. And in addition to the following, and it calls them methods, not exactly methods, ADA boost classifier, bagging classifier, and k-fold, and train test split. So you can see here, I'll go ahead and start stepping through it. I did import sklearn, pandas, numpy, ensemble, pretty much all those that are being done, that are being spelled out. And then I did import from the SK ensemble, essentially namespace, I imported the ADA boost classifier, bagging classifier, and then down underneath model selection, k-fold, and train test split. So you can see I pretty much did it, and also if you take anything away, maybe knowing the namespaces those things are in. And because I typically end up using them, pretty much import NumPy, pandas, and matplotlib pretty much all the time. So maybe not the most efficient thing, but it is useful sometimes. And then I went ahead and imported metrics, cross-val score, mean, and std from NumPy. First step is, or the step 2 number there is kind of the first thing you really think about doing, which is loading the CSV. So I read the CSV into the data frame, and then the next step is to kind of explore the data by printing out, say, the first 10 records, which is what we see there, and then maybe take a look at describe. Dataframe.describe gives you some pretty useful statistics around the data frame, such as the counts, the mean, the standard deviation, min, max, and the quartiles, so basically, so if you know the distribution. Fairly useful, but again, kind of the minimum. Another thing that might be useful is to know what are the unique values for diagnosis, and that's where you can use dataframe the column of interest unique, and it'll give you back the unique values along with what is their type. And so your next step is to most likely convert those from essentially categorical features to numeric features using the map, and that's what I'm doing here. And it's basically doing data frame, and I'm setting a target column from to be the mapping of that, and to be kind of consistent. We'll go ahead and copy this down and print that out just so you can see what it looks like now. And you can see now over here on the right side there should be a target column, and those are all ones because probably all these are ordered by the diagnosis, being malignant being at the top. I did something similar here with the head just to pull the first few, and that's just showing the first 5 versus the first 10. And then now you may want to take a look at the columns that are available inside of your data set. And the way I kind of approach this problem is, it's almost like you can see my thought process by how I organize the notebook. Not saying it's necessarily the way to do it, but it's the way I typically do it. I typically go through and kind of build up stuff as I go, In this case, taking a look and see which one of these columns do I care about, and those are the ones I care. So I created an array of columns of interest, and I got rid of everything that's not a column of interest, and so that these are only the things that we care about now. So there should be target, and then the values that are likely to contribute to that target. So anything else was removed. So diagnosis and ID went away, not terribly meaningful, as are the things like worst. We don't care about those too much. We care about the mean, right? So, and then the next step, obviously, I just did that. I took a look at the thing. So then the next step is to take a look, are there anything that needs to be cleaned? This is one way to do it. Pretty handy little script to keep around. You might want to steal it. Basically, the idea here is you say for all of the columns in the data frame, print out the column name, its data type, and how many, if there are basically are any null values, right? So there's no null values, so that gives you some indication that there's nothing null. And then at the end, go ahead and do a describe just for completeness. So I went ahead and run that again. So then your next thing is to go through and start looking at creating your features and your targets, so separating out that data frame into the two data frames that you care about, one containing the targets, one containing the features that correspond to that target. And then you want to do the test train split, passing in your features, your targets, and your basically your percentage that you want to be in the test versus the train. And so in this case it goes through and it separates those out. For completeness, you might want to go through and do something like sorry, X train head. Oh, that's right. It's not a data frame. So anyway, back on script. That's the basic idea is to. You could probably just print it, right? Just to see roughly what's in those values, and also so you can see that the values have a reasonable split between the targets that you're interested in the training size or training set anyway. So your next step would be to create the classifiers that are of interest. In this case, you're basically given the requirement to do two different ones, one being the ADA classifier, the other being the boost or the bagging, so to do bagging instead, the bagging classifier. So I'm creating that here, but I ended up really not needing it. Probably should remove that, but it does give you a sense that you may go through and create something one time and then move away from it later on, because what I ended up doing was writing a function to do the classification, because it just seemed like a cleaner way to do it. Lots of different approaches. It's just what I ended up doing, but it does tell you to make a train or make an object of it, do some predictions, which we're doing here. So I created something called model after having fit the ADA boost classifier to train on the data. Then I do some predictions and look at the accuracy of those predictions. So you can see my accuracy is not horrible, about 93%. So that's better than you'll get in a lot of stuff. So a good idea to take a look at. Then you're told to do the cross-fold validation with or cross-validation with 5 folds, to use k-fold and then cross-val score to come up with the value across those. On that, the accuracy is actually a little better, 95, a little over 95%. So then you're asked to record the records for each cross-validation run and print them out, and so on. And then what I did to do it a little cleaner of comparing them, I basically create functions that did both ADA boost and bagging. And really there's not a whole lot of difference. This probably could be better because there's some common code here between. If you look at it, pretty much all of that is the same between the two. It's just this, what is the classifier, that really kind of is the difference. And then I believe there was some difference potentially on some of the metrics, maybe. I'm not even sure there was any difference on the metrics. But So that gives you a basic gist of kind of the approach I use, and at the very end just call the function. Like I said, this is a starting point. Don't view this as being the answer. It is a answer, and probably not a fantastic one at that. But it does kind of give you some hints as to how you might attack the problem, and hopefully it doesn't bias anything too much. But you do want to think of, or at least I think of, this kind of development, this type of work, as a very much of a iterative process where you may create several cells just to kind of almost show what you've done from an experimentation perspective throughout the process. And so with that, I've pretty much said what I have to say. If you have questions about any of this material, let me know. You're making good progress in the course. So keep it up. You're on track to finish a bit ahead of time, which is perfectly fine. That's one of the beauties of this sort of course, is that you can wrap it up at any point. You don't have to go slow if you can go fast. So competency-based education is a cool thing. So if you have any questions, let me know. Otherwise, I will speak with you on Monday.